Hello. Prove using truth table. Coming up, the next. Time to prove the chain rule using truth table and ensure that the result is forever true. Forever true is also called tautology, means whatever input you supply, the answer will come as true. Now let us check it out. How? They're saying if P implies Q and Q implies R, that implies P implies R. Okay, it's quite confusing. I remember my student days, it was very confusing. How will you do it? You have to break it up into pieces. Like P implies Q and Q implies R. Whatever is the result, that result implies P implies R. Then the final result is going to come as forever true. Now let us break it up into small pieces and see how the pieces are working. See here, P implies Q. We have renamed it as X. P implies Q will be true whenever either P is 0. So whenever P is 0, P implies Q's first 4 variables are coming to 0. For 3 variables, there are so many combinations. Now, when P is 1 and Q is 0, no, it is not allowed. There are 2 cases here because of 3 variable combination. If P is 1 and Q is 0, these 2 cases, no, it is not valid. We cannot allow Q to become 0 when P is 1. We can allow Q to become only 1 when P is 1. Then only P implies Q will have a meaning. So this part is done. Now we come to Q implies R. Q implies R. Q implies R will become true when Q is 0. So when Q is 0, Q implies R, which is Y, is okay, 1. There are 2 more cases of Q as 0. Then okay, they are again 1. But when Q is 1 and R is 0, no, it is not allowed. But when Q is 1 and R is 1, yes, it is okay. When Q is 1 and R is 0, no, it is not okay. But when Q is 1 and R is 1, yes, it is okay. Hence, the result of Y comes like this. You have to pause the video and understand how X is coming into existence and how Y is coming into existence. And then is the X dot Y, which is the left side, this part. P implies Q and Q implies R. This is going to be simple. When both of them are 1, the result is 1. Any one of them is 0 and the result is 0. Hence, we are going to see, if you look carefully, you will find there are 4 cases when the result is coming to become 0. 1, 1, 0, 1, 0, 0, 0, 1. Then, now we look at P implies R. P implies R. Whenever P is 0, R is free. So the result is 1. But if P is 1, R is caught. 0 for R is not okay. And therefore there are 2 cases when this is 0. When both P and R are 1, then the result is 1. So last 4 cases there are 2 zeros and 2 1. And then we need to check M implies N. To understand M implies N, here whenever M is 0, this one and the 3, the output has to be 1 and it is 1. Okay, why? M implies N, 0 implies 1 is allowed and 1 implies 1 is also allowed and 1 implies 1 is also allowed. 0 implies 0 is also allowed. So 0 implies 0, 1 implies 1, 0 implies 1 allowed. Only case which would have caused a 0 was a 1 here and a 0 there. Now you see, there is no such case and hence all of them are ending up in becoming 1. Hence this is a forever true case. That means if P implies Q and Q implies R, then P implies R is a forever true case. Coming up are more. Okay.